So when I first started working in the United States, that was 2012. I was a dude in his late 20s and a normal dude. And as a normal dude, I need a credit card, I need a car loan. I went to apply for both. I got rejected for both. And the reason was they told me my FICO score is too low. And later, because I was hired by Capital One, so Capital One has this program that allows employee to apply for the credit card too. So I went to the branch, they were so kind, they gave me a credit card with $300 credit limit. So it was very humiliating because I had a credit card back home in China, I had a car loan back home in China, and here I'm trying to live a normal life, and I was told because my FICO score is too low, I couldn't live a normal life. So at the time, I had to pay for two bureaus to get my credit reports, and one of the bureau had my credit score as like 500 some score, and the other one has 600 some score. So even the bureau have inconsistent scores. So I thought to myself, hey, this score is so lame. If one day I get to decide whether to use that score, FICO score, or not, I'm totally gonna just not use it. And if I get to meet the FICO people, I'm gonna say in their face, hey, your score is so lame. So, and I got the opportunity to do that fast forward many years to where I am today, working for PNC as a lead of model developer. I have many chances to meet with FICO core developers and many chances to meet with the salesperson. And I think I successfully helped my company spend millions of dollars on their product each year. So I'm doing exactly the opposite to what I wanted to do. So why is that? And FICO is it's really the golden standard of credit modeling. So that's why I'm going to talk a lot about FICO today, because it is used everywhere. It is used in, target your customers, right? Making sure you want to target the right customer segments. It is used in underwriting. Make sure that you don't want any people that falls below certain credit score, so that you don't, it's aligned with your credit policy and all that. You manage account using FICO score. You do collection based on FICO score. FICO score may change, so you get to observe some people may be degrading in their credit. This one is my favorite, model input and model baseline. So in banks, whenever you're building a model, like a classification model, which try to judge the credit risk, a lot of time your baseline, so think about a classification problem, and if you use the area underscore of the ROC curve to measure how good your model is, typically your baseline is the 45-degree lines, which is 0.5, right? But in this case, FICO is the baseline. FICO is usually 0.6 or 0.8 in a lot of the bank data. So it is quite hard to beat FICO, right? And if you're a model working in a bank and you're not able to beat FICO, you work a couple of months, build a model, not able to beat FICO, people will be sort of questioning your modeling capability. So that's why FICO is like playing a big role in everything we do in the lending business. So to understand FICO, we need to understand what kind of data it is using. So this is a typical information or credit report that lenders, like a bank or a financial company with a dealership, that reports to the bureau each and every month. Think about it as like 5 information zones. Number 1 is information about the customer, where he lives and all that. By the way, where people live and the zip code, it is a highly predictable attribute for credit profile, but it is against the law to use it because it's discriminatory, right? So in the United States, you cannot do that. The only thing you can use is these 4 categories. So public records, any bankruptcy, any tax lien on the account. We Chinese American are usually not familiar with those. Whether there's a collection, which means they have derogatory accounts in the past and people try to collect on their accounts. tree lines, this is typical, like you have a car, you have your auto loan, you have any kind of lending product that you have that gets reported to the bureaus, the free bureaus each and every month. Inquiries indicate how credit hungry you are. So if you try to apply for a lot of credit cards, that's not good for your credit score. So with these data, think about there are probably like 200 million US consumer each and every month, and every consumer may have a couple of trade lines reported to the bureau. It's a giant data set that's managed at the bureau. And what they do is they typically summarize all those information into something that can be put into a model. So, for example, like this attribute, it is summarized from the credit amount of the bank card. This second one is inquiry made in the past 12 months, and this one is about mortgage. So there are, depending on what kind of version of the bureau records or attribute you are working with, but typically we are dealing with more than 1,500 of these kinds of variables in our models. And by the way, if you have any question, please just stop me and ask. I want to make this more conversational. Okay. So this is all this information turned into feature, and then you can put into the models. So let me ask you a question. With all this data, there's so many interactions in between this data. What do you think is the algorithm behind the FICO score? So I put up a timeline about some of the popular classification algorithm, and these timelines are my understanding of when they become relevant in the industry. So you have logistic regression in the 50s, neural network, there's a boom in the 80s, tree ensemble method, many people are using it today, start really gain some traction in the 2000s, and deep learning, right? Everybody's talking about deep learning these days. So what do you think, please give me a show of hand, that you think the model algorithm is logistic regression? Okay, it's about, I would say 15%. Yes? Neural network. Anybody think that the FICO score is based on neural network? No one? Tree ensembles like GBM, XGBoost, random forest, a few, thank you. Deep learning.
So what's the difference between a neural network and a deep learning?
So neural network,
Actually,
yeah.
I think they are pretty much the same, just with different name.
Yeah.
Right.
There's definitely argument about deep learning being the new marketing campaign of the neural network. That's definitely that, but there's something different about the latest application. For example, when you think about convolutional neural network or recurrent neural network, there's a lot of things that's outside of the traditional type of fully connected neural network, right? So that's I would say this added portion that deal with feature engineering added to the neural network. So that's why they becomes pretty powerful today. But yeah, in I would say 80% of the time it is not something really new. Right? I totally agree with what you just commented. Any other question? So the answer it is logistic regression. That's what they've been doing for the last 25 years. And why is that? I mean, logistic regression is just a linear model, right? You couldn't even do a lot of the complex stuff and capture all these different kind of nuances in the data. So I actually met with the FICO core modelers. So they did try to use a GBM, a gradient boosting machine, and compare with their current model. What they found is there's only a 2% lift, less than 2% lift on the model performance. Now they did mention that it is so much easier to build a model because it only costs them like 40 hours versus traditional 800 hours. But I was blown away by this 2% lift, and they also mentioned a couple of problems with the machine learning. So why is that? Why is the FICO score not able to, the GPA not able to beat the current FICO traditional kind of logistic regression? One aspect of the problem, the reason is that they've been doing this for 25 years. They're really good at it. So here's a concept of how do you use human expertise to capture all this interaction in your data? What they did is really try to segregate the customer base, consumer base into very refined segments. So within each segment, people behaviors tend to be homogeneous, and they'll be able to use logistic regression to capture the behavior inside this subsegment. By the way, this is just a concept, not the real FICO thing. I don't know what they're doing. It's a trade secret, but probably something like this. And they also have handcrafted feature engineering. So when I think of these FICO modelers, I think about a chef in my parents' hometown. They make this really my parents' hometown in Chaoshan, and they make this really tasty fish balls, which can bounce like ping pong ball. Right? It's very nice texture, but they're all handmade. There's literally thousands of hours put into making those fish balls. Like, you need to beat the fish paste, you need to mix the fish paste with the different kind of ingredients, and they just never use machine to do that, because once you use machine to do that, it becomes not so tasty. And when I think of FICO modelers, they are the fishball maker in the credit score industry. The other thing about using machine learning is that you need to worry about regulations, right? So in the United States, there's a Equal Credit Opportunity Act, right? And I just took some of the stuff from the CFPB's interpretation of that. So first, a creditor must disclose the principal reason for denying an application or taking other adverse action, which means whenever you go to apply for credit, the lenders cannot say, hey, I'm not going to lend to you. He's going to say why, right? So that's a really a model interpretation problem, right? And CFPB says one method is to identify the factors for which the applicant's score fell furthest below the average score for each of these factors achieved by applications whose total score was, this is a really lengthy sentence, but basically means that you can give out the reason by compare the application to the people you merely just approve, right? But that's actually a really complex math problem, because the people you merely approve, there's many reasons you approve them. There's many reasons they are just above the approval line. So it becomes a really complex math problem. If you're using machine learning algorithm, it's not so easy to actually do that. Actually, I'll show you the reason in the next page. And then the last sentence just basically saying, hey, you cannot just approach this problem using some other model. You have to tell the real reason why you are rejecting the customers. Which means a lot of the fintech company, they come in and say, hey, we know how to do machine learning, we know how to do the adverse action code, we're going to use Lime, we're going to use this kind and that kind of technology. They probably haven't read this, right? Lime, for example, you guys are familiar with Lime, right? It's a locally interpretable agnostic algorithm which try to approach the decision boundary of the algorithm, but that would go against this requirement by the regulations. So to give you an example, right? Let's assume this is the relationship between your x and y, and let's assume this y is one of the attribute, maybe month since your most recent derogatory event or delinquency, something like that. So as you go further away from your most negative event, your likelihood of being a bad customer is decreased. Okay, assume that's this chart is talking about. Now, see, this chart is not, this relationship is not monotonic, right? And this is typically what a machine learning model can capture. like these nuances in your data. To make it worse, this line is just an average situation, but for each application or each customer, they follow a different pattern. And the reason machine learning will be able to capture, to get a better model performance is usually capture these kind of nuances in your data. But think about it, you need to give the customer an actionable reason why he's rejected. You cannot say, typically it goes like this, your most recent derogatory event is too recent, right? That could be a reason. But if you say, hey, man, your most recent event happened at a bad timing. If that event happened 1 month before or 1 month after, you'll be fine. That's not going to be okay, right? So that's why in a logistic regression situation, if the y-axis is the logic, this will be a straight line, right? So wouldn't be a problem. Everything will follow the same pattern, and that's why it becomes a little bit hard if you use a machine learning model on the underwriting model like FICO. Now, over the years, there are some companies actually crack this and able to convince the the regulators, model validators, right? Some people I know, Capital One being one of them. Capital One have productionized GBM model for their underwriting. Bank of America have some of them because Bank of America hires some Capital One people. I think PNC, we are really, I can say we crack the code too. We just don't have the right infrastructure to implement it. Zest Finance just launched a collaboration with Discover on their personal loan. They're gonna use GBM, or actually they're using something very complex. They're using GBM combined with neural network, doing ensemble, and then seems to be doing pretty well, and they claim they were able to convince the regulators. But I'm not going to tell you how we do it because this is a trade secret. But welcome to talk about the concept, after the meeting. So the regulators' opinion on machine learning, right? Like we talk about you just talk about some of the applications here. Mostly it's around fraud marketing. That's easier to do machine learning model, but credit underwriting, it's a little hard. And I encourage you to read one of the posts that the board of the Fed wrote back in last year. Contains a lot of information. But basically, there was a couple of points. Point number one, they recognize there's a growing need and growing use in the financial industry using AI and machine learning. And secondly, they think people should be cautious because in the past, whenever there's a new stuff, a new innovation in finance, it tends to come with some problems. So people need to be aware of the risk. And the third point is that they don't know where this is going to end. So they welcome people to join the discussion. So if you want to do a machine learning or do data science in the banking industry or financial service industry, I think it is a great timing because it will help shape the future. So I think at this time, many of you may be asking, hey, what's this guy doing? I thought he's a machine learning guy and he's talking about all these bad things about machine learning. I think there's definitely a lot of opportunities. I'm sorry, how are we doing in time? Fine? Yeah. Right, so it's a little bit hard to see at the back, but so let's just go back to feature engineering. So think about all the records from the lenders collected each month, right? About the trade, about the inquiry, about the collection, public records, judgment, bankruptcy, blah, blah, blah. And then you have all these records across different industry, mortgage, home equity, installment loan, auto, personal installment loan, student loan, so on and so forth. And you have how the customer behave, right? The payment status, what's the age of those trades and the balances, utilization, available credit. So many information and what they're doing to come up with these features. basically just these several functions. Take an average, take a sum. What's the worst ever delinquencies? What's the highest maybe amount, balance amount, or highest credit limit? What's the lowest? Is it a new? This is new, right? Newest and oldest. And then is there a presence of something, maybe an event, right? All this function, I can say just some of these, like all this feature engineering are just using this function. So can machine learning actually learn some more creative functions other than this? So I did an experiment using a Cargo Santander competition data. So back in 2016, Cargo has teamed with Santander to do a product recommendation to solve a product recommendation problem. So basically what they collect is the customer's information, like where is this customer live, what's his age, what's his or her age, what's his or her, the province, and what's the channel they apply for the product, and the agenda. Those will be like dynamic information, but each and every month they collect the usage on the Santander data. So they have like 0 or 1 to indicate whether that person used that product in that specific month or not. And the target is trying to use all the historical information and try to predict the next month usage. So again, dynamic information here, and some static information here, right? So I actually try to see if person changed the agenda, because I think that will indicate some behavioral change. I unfortunately couldn't find that. So in a traditional type of traditional statistical language, this is merely a panel data set, right? It's nothing new. So think about how you would do feature engineering of this data. Think about this data as the 3-dimension data. So you have the customer on 1 dimension. But most of the model we are dealing with needs to consume a 2-dimensional table, right? So what you need is to compress this time dimension and come up with something, right? Just now you saw that the sum of something, the average of something within a certain window, right? You come up with something that puts all this information in the 2-dimensional table, and then you can put into a classification algorithm like XGBoost, and then just run it and get your results. But what if we don't need to do that, right? Because you need to come up with those functions. What if that you think of these customers as a picture, each customer as 1 picture, and the customer, for example, this is the time dimension, this is some of the static information, dynamic information. Think about the customer have these information that change over time, but in a picture context, they become an edge or become a pattern that you can try to detect using maybe what is good for a picture classification, convolutional network, right? So what if you just plug this data into a convolutional network rather than trying to come up with something like, hey, whether that customer used this product A at a certain time, and then next time he doesn't use it, and combine with some other product usage information. It becomes like infinity possibility for you to do the feature engineering. So convolutional network, not sure, like I'm by no means an expert on convolutional network, but I'd like to actually hear, one of the, I think there's an expert in this forum that will be able to share. But the convolution network is really good at handling pictures because it has these convolutional layers before the fully connected neural network layers to extract useful patterns in the pictures, right? So if you look at the Wikipedia and where it talks about what's the benefit of using a convolutional network, it says the independence from prior knowledge and human effort in feature design is a major advantage, right? So in this case, you should be able to use a convolutional network, treat the customer as pictures, and then able to come up with the useful patterns. And by the way, just a little bit more iteration on what is a CNN. At the very basic unit of the convolutional operation. It's doing something really simple. It's just a simple mathematical calculation. So think about you have a picture, right? You have pixels, and the pixel can be translated into numbers. So let's say there's an area in the picture that have 10 on the left and 0 on the right. So you will see, there's actually the picture have a horizontal line in between. How do you detect that horizontal line? So let's say you have a filter, you put that filter on this area, and then you just do calculation by multiplying the elements across these 9 cells, and then you sum that 9 cells. So here, this guy put in here and do the calculation, becomes 0, and then you move the filter one step ahead, and you do the calculation, that becomes 30. Do it over and over again, you get to something like this, right? And this guy indicates there's a vertical edge in the picture. So by changing these filter values, you can detect different patterns in the picture. So this is an example. If you change the sum of the value, you'll be able to just get an edge or just get some blur line about the picture. Like I said, I'm by no means an expert on this, but I guess the point is the convolutional network, the basic ingredient is not that complex. So I built a model on this, and then this model has 2 paths. This is a deep learning model. One path handles the dynamic information, and the other path handles the static information. It took me about like 3.5 weeks on and off to do this. It was trained on just a home computer with Keras and TensorFlow backend. It's about only 50K parameters, so that's a really small, actually a very small convolutional network. And what's the result? I actually didn't have a lot of time to tune the L1 and L2 hyperparameters. So the model was able to rank 26th on the private leaderboard and 22nd out of the public leaderboard. There were about 1,800 teams attending that contest. By the way, the matrix is the mean average precision. So these guys actually spent a month on the contest, and just to give you some background, to win the Kaggle contest, you need an ensemble model rather than just one model. But this one model was able to actually achieve a pretty good result, which shows there's great potential that the model is actually very competitive, and we were able to capture a lot of information. I didn't do any feature engineering at all, but and was able to capture this. So I think there's great potential if you use this in transaction data or a sequence data that will that capture your customers' historical information. So interpretation is something that really necessary, right, in the bank industry. So unfortunately, there's not a lot of CAN interpretation tool right now for a problem like this. But the basic math tells you that you can actually do a first order Taylor series approximation, right? Because the network is differentiable. That's how they do back propagation. Now, what you can do is that you do a Taylor approximation. You see the gradient. Is it the gradient positive or negative, and how big it is? So here, this is example for this customer. If that customer used tax product in the last 2 months, they're more likely to use credit card next month. If it used direct deposit in the last 2 months, more likely to use credit card next month, because these are all red and warm. Apologies, a little bit hard to see, but this will tell you that what is driving the prediction. And obviously that customer here is that if the customer used credit card in the last month, then the chance of using credit card this month will be low. And the reason is this is because the target was set up in a way that they don't care about whether the customer used a product if last month he or she already used it. But the model was actually actually able to capture that. So which means the model is actually doing a good job of capturing the target. Oh, thanks. So basically that was it. I go over this pretty quickly. So if we have time, we can get some questions. Yes.
One question. You have done the experiments trying to shuffle the rows to see if the CNN are different.
I did not have the time to do that, which is a good point because people, whenever dealing with sequence data like this, people will use INN rather than CNN, right? But INN will only capture the time dimension information, not the product interaction, right? So here I arrange the product in one way, but if I arrange the product in a different way, I may get a different result. So that's totally valid. But I did not have time to do that.
Okay, the last example, did you think about any trended attributes that might help you improve the model prediction power?
So I guess the point here is that all the trend, if there's a trend that helps prediction, it should be captured by the CNN. My point is not to use human brain to come up with those features, but rather use CNN to capture those information. And I guess in this case, I proved my point, right? It actually captures some trend information in the last several months.
You mentioned about product interaction.
So back to the problem, it is about predicting what product that person is going to use the next month based on the product usage history. So there were 24 products, right? Credit card, auto loan, different kind of products, right? And deposit, things like that. So this is like product dimension. If you lay this out, whether that person used that product in a certain month, then that's the product dimension. Now, we also have a time dimension which capture all the usage history. So that's what I mean the true dimension of information here. Go ahead.
Oh, so like I'm new to modeling and data science. In general in banking and finance, when you run a model with 1,500 features, like about how many that do you actually take in, or do you use all of them?
Right. So it depends, right? I hate to say that, but it depends of how many features will be able to capture, let's say, most of the information.
Okay.
I would say if our legal team and our compliance team, they are willing to review 1,500 variables, I will totally do that. But typically, in the credit risk model, we are looking no larger than 60, let's say.
60.
Yeah.
And the second question is like, at what point do you feel like there's overfitting your data? Like, how would you tell?
So overfitting should be rigorous test before you even come up with final model.
Okay.
Right? So you would have to have different data set, typically out of time data set, to get a sense of how your model is going to perform in future population. So you will need to control that. And when you are training a model, we typically see the gap between your training and validation, and you know what's the gap between, what's the overfitting situation between a model. But I think that's a good question because the more powerful the model is to capture nuances in the data, the more careful and more time you need to spend on validation, on making sure that the model is not overfitting. You have a question?
Yeah, so considering you have the time dimension, which is like a sequence, why do you choose like CNN instead of like other models like RNN or how?
So there's an INN model in this contest, and it reached 15 on the leaderboards. So maybe the INN is a better choice. INN definitely have, you will be able to capture longer history or longer dependency in the history, like if your target is depending on longer history. Now, the reason I choose CNN is because I want this product dimension also, right? Because if you're using IN, you still need to come up with like interaction between products. But here, I just want the machine to do it for me. But IN also, like, it's a good question because IN won't be able to capture. It's like if there's a temporal dependency, it only captures information within that small window, right? So that's something you need to pay attention to if you're training a CNN model. Now, it is interesting. I met this guy who actually built his company based on deep learning on investment. Right? We typically say, hey, investment like stock price, historical stock price are not useful for prediction, future stocks. But this guy actually built his company on deep learning on investment, and rather than choosing INN, he's using CNN, but he's changing the time series, transform the time series in a really complex way into a picture representation, and then use that. And then put those into CNN. And he told me the reason is because CNN is so much easier to train. When you have a lot of data, IN tend to be very slow if you need to train that.
Oh, I have a question. So what's like the data structure you use in the CNN? So in CNN you have the depth, right? You have the depth, like the third dimension of CNN, which is like here it is the time series, which is the date here, right?
Yeah.
But for the depth, you want like the certain structure all have the same depth, right? So the third dimension should be like given. So is it like, so what's like, how do you assign like those data points for the third dimension? So is it like once there's a trade, once there's a deal, then there's a one on the third dimension? So what's the third dimension looks like?
So, but yeah, the depth. Do you mean for example, if you have a picture, there were three layers, right, of information.
But here you have the. Like,
so think about a black and white picture, which only have one channel.
Yes.
Yeah. So that would be comparable to in this case. This is a black and white the pictures.
So if there's no deal in a certain given date, then probably like in that layer it's empty. Like for your data.
It's going to be zero.
So all of the data will be zero if it's empty.
If there's
no like trade.
Yeah, there's no activity. Yeah. The last question, maybe.
Okay, so very good presentation. I learned a lot. So you mentioned that one reason the machine learning, deep learning is not widely used is because it's hard to interpret the result, the driving factor, right?
Yeah.
Maybe can you elaborate on what is the state of art in terms of finding interpretations for this machine learning method, right? Model. What are the existing methods to finding the driving factor? You mentioned one, and do you see a future, right? Do you think that ever we can make this black box white?
That's a great question. I think I can talk like 1 hour about that. But just to give you some example, shape-fitted value. Have you heard of shape-fitted value? Right. It is. First, let me back up a little bit. Interpretation is a really human concept. It's a very subjective concept. Shape-fitted value allows you, it's a game theory problem, so it allows you to pass the impact from different drivers into like a aggregation, like an addition kind of format, which means, for example, if I have all these attributes, all these features, they're interacting with each other. What the regulator wants is that you need to give me something like a list of ranking that tells me, hey, this is the biggest reason, this is the second biggest reason, and all these things may add up together to something that makes sense. So shape-fitted value is exactly doing that. Let's say you and I and Jidong go to a restaurant and we order different food, right? And this different food costs different money. And then we need to, we also share some food, right? So how do we make sure that we can break up share the bill in a fair way? That's what shape-fitted value is doing. So nowadays people are using this theory on machine learning models and try to try to come up with a very fair cut of like which attribute is doing the contribution. But that's, like I said, the topic can last a long time. But shaping the value is looking very promising. Yeah. Thank you, guys.